So my screen is visible, students?
Yes, sir. Visual, sir.
Okay, good. So today we shall discuss this numerical. Please see. This is a bar. Interesting numerical, and in GATE exam, most of the time such types of objectives are framed. So this is a bar. Here on this bar, axial load of 50 kilonewton is acting. 50 kilonewtons. 50 kilonewtons is acting, right? Then suppose this is A, this is B, this is C, and this is D, right? At this plane, right, at this section, this is the axial load of 80 kilonewtons. It is given in the example, 80 kilonewtons. And it is acting in rightward direction. This is 20 kilonewtons acting in leftward direction. 20 kilonewtons. And this is again 10 kilonewton at this section acting in left direction. So now try to listen this carefully. The length of this section is suppose length of this section is suppose 600 mm. Length of this section BC is given 1000 mm. And length of this section CD is given 1200 mm. Now, first of all, in such types of numericals, we should split these three parts into a single one, and we shall try to draw the free body diagram for each section. In this, the diameter, this is a bar, and this bar is having constant, or you can say same diameter. So the diameter, and it is circular in section, but front view we will get like this. Diameter of the bar is 36 millimeters. All dimensions are given in millimeters. Forces are given in kilonewton. So diameter I am abbreviating as phi. So diameter is given 36 millimeters. And this is subjected to axial pulls or forces as shown in figure. Now our aim is to determine, it is obvious because of these axial forces there will be a change in length. Please watch my previous video on compound bars, wherein I have explain in detail how to determine the change in length. So our aim is to determine the change in length in such types of bars subjected to axial pull. And modulus of elasticity E for this bar is 200 gigapascal. Now it is quite obvious that this is made up of the same material, so the modulus of elasticity is same for all the sections and it is 200 gigapascal. As you know, giga means 10 to the power 9, pascal means Newton per meter square. So first of all you convert these units. Pascal means Newton per meter square, so you convert it in newtons and millimeters like this. So 200 gigapascal, if you will convert it, it will be 200 giga means 10 to the power 9 and pascal means Newton per meter squares. So it will be Newton per meter square will be converted into millimeter square. So 10 to the power 6 millimeter square. For unit conversions, you watch my previous videos, you will get. So 200 gigapascal means 200 into 10 to the power 3 into 10 to the power 3 newtons per mm square. So this is the value of E you have to use. Now all your units, 50 kilonewtons means 50 into 10 to the power 3 newtons. So all your units will be in Newton and millimeter. So first of all you try to maintain same units whatever you wish for and then proceed. So here you break up these three sections in three different parts. So this is your section AB, right? To make you students comfortable, I am trying to draw one below the other so that you can easily grasp the concept. This is B, this is C, this is your second section, this is your first section, right? So this is your first section, this is your second section, and the third one I am trying to draw here, that this is your third section, this is C, D. If you will try to draw the free body diagram, so first left hand side, this is 50 kilonewton force towards left. So this is 50 kilonewtons towards left. Then at this section, if you will study, 80 kilonewton towards right. Clear? Now this is 80 kilonewton towards right. So as per this section is concerned, AB, if 50 is acting in leftward direction, the reaction, this 50 will be in rightward direction. But at this section B, 80 kilonewton is acting in rightward direction. So if you look at this B section, 80 kilonewtons should be in rightward direction. So to make 80 I will have this type of value here. Now you see this section 50 rightwards plus 30 rightwards 80 kilonewton in rightward direction. This section is justified here 80 kilonewtons in rightward direction. Now as 30 is in rightward direction, at this section 30 kilonewton force will be in leftward direction. But at this section you are getting 20 in leftward direction. So 20 in leftward direction you can get only when 10 kilonewton force will act in rightward direction. So now if you will look at this section 30 in leftward, 10 in rightward, so net will be 20 in leftward direction. Here it is justified 20 in leftward direction. Now it is obvious that 10 kilonewton is in rightward direction, so you will get 10 kilonewton in leftward direction. In this way you have drawn the free body diagrams for each section, and you have to ensure that here it is 50 leftward, 50 leftward, 50 rightwards plus 30 rightwards, 80 rightwards, it is 80 kilonewton rightwards, 30 leftward, 10 rightwards, so net 20 leftward, and this is 10 rightward, so 10 leftward, this is 10 leftward. In this way you have to ensure after drawing the free body diagram for each section. Now if you will refer to my previous lecture on compound bar, you have equation to determine now to calculate the change in length for each section. So the equation for delta L is PL. You will get the derivation of this also in my previous lectures. PL upon AE. So please apply this equation for AB. P will be 50 kilonewtons. So I am using this Newton. I am using this Newton and millimeters unit. So in newtons and millimeter unit you have to convert kilonewton to Newton as 50 into 10 to the power 3. That is newtons. P into length. What is the length here? Already given 600 divided by area. As the rod is circular in shape, area will be pi by 4 into d square. That is pi by 4 into d square. Remember one thing, you have to see diameter is also in millimeter. It's okay. So pi by 4 into 36 square into E value. I am not writing here again and again the same value. E value you know, 200 into 10 to the power 3 newtons per millimeter square. So in this way you will get the change in length for this section AB. Can anyone calculate and tell me the value? Then you have to use the same equation here. PL upon AE. P is 30 into 10 to the power 3, because kilonewtons are converted into newtons, multiplied by length. Length is 1000. divided by area. Area for all the sections will remain same. E for all the section will remain same. So same pi by 4 because diameter is same throughout. Pi by 4 into d square multiplied by E. I am not writing here again and again value of E. You substitute this value here, E. You will get the change in length for this section BC. When you will use for this section, again the same formula to be used, P 10 kilonewtons, convert it into newtons. Multiplied by length 1200. Again same area, pi by 4 into d square. So diameter is 36 mm multiplied by E. E value is same throughout the rod, same material is used in this. So 200 into 10 to the power 3. Now
Excuse me, sir.
1 minute, let me finish, then we shall discuss. Now in this you will observe that this is the tensile force. Tensile force means here the length will increase because this spool is tensile. So whatever the value you will get, that will be plus. This is the compressive force. So definitely your length will get shortened. So this is negative. Here also compressive force, your length will get shortened. It's negative. So net change in length delta L will be equal to change in length for the portion AB right minus change in length for the portion BC minus change in length for this portion CD. You have to calculate and you will get the net change in length in this section. Please ask. Yes, please ask.
No, sir, my doubt was clear.
What was your question? Please, you can.
Sir,
Please.
actually, I was asking that as in section BC, there is a compressive load we have.
Yes. That's why
Why we are not using that minus sign?
yes. Because if you have to determine the net change in length, then definitely you have to take this into consideration, that whether it is an axial pull or whether it is an axial compressive force. So
Yes, sir.
you can try after this class the change in length. You will get minus, I have solved this numerical, you please verify this solution, minus 0.118 millimeters. Means by using this method to solve such types of problems, now objective question can be framed like this, that whether this rod, the length will be increased, a rod of uniform cross section with 36 millimeter dia having modulus of elasticity 200 gigapascal is subjected to the following axial loads: Option A, length will increase. Option B, length will decrease. Option C, length will be constant. So you have to use this. After that you are getting minus 0.118 millimeters. Means the length will decrease. Right? And by what amount? 0.118. So very nice and interesting actually such types of numericals are. So anyway students, to before watching this video, I shall recommend you to watch the video of compound bars, and hopefully you will enjoy this. Thank you very much.